Hello friends, welcome to my YouTube channel Deep's Study Room. Today in this session we are going to see a topic of material science and metallurgy. Material science and metallurgy is the subject which is offered in diploma, degree, and also it is useful for ITA students, Master of Engineering students, PhD students, all. So most important topic of material science and metallurgy, which is heat treatment of ferrous alloy. Also, heat treatment is one of the most important thing in the mechanical engineering. So let's see what is heat treatment and how this heat treatment is carried out. Heat treatment of ferrous alloy. The various microstructure described far can be modified by heat treatment technique, that is by controlled heating and cooling of a alloy at various rates. This treatment induced phase transformation that greatly influence such mechanical properties as the strength, hardness, ductility, toughness, and wear resistance of the alloy. By performing this heat treatment, we can obtain a desired property in the material. Heat treatment is carried out by heating and cooling various metals and alloys at different temperatures. By varying the temperatures, we obtain the different properties such as hardness, ductility, toughness, wear resistance, etc. The effect of thermal treatment depend on the particular alloy, its composition and microstructure. This is known as heat treatment is also known as a thermal treatment, which depends on the composition and microstructure. As we know that alloy is the mixture of metals. So when we are going to perform a heat treatment process, then the properties which are obtained after the heat treatment depends on the composition of the alloy, that how much percent steel is there, how much percent copper is there, how much percent tin is there in a particular alloy. It depends on the composition during the treatment. The degree of prior cold work and the rate of heating and cooling during the heat treatment. The process of recovery, recrystallization, and grain growth are the examples of thermal treatment involving change in the grain structure of the alloy. By performing this heat treatment, the microstructure, the small grains of any metal alloy, which can be seen by the metallurgical microscope. When we will see the grain structure after performing the heat treatment, we find some changes in the grain structure. So that is we can able to see by a metallurgical microscope. This section focuses on the microstructural change in the iron carbon system. Because of these technologies significance, the structure considered are perlite, benite, martensite, spheroid, and tempered martensite. The heat treatment process described are annealing, quenching, and tempering. Okay, so we have seen here the names of some structure: benite, martensite, perlite, spheroid, etc. And also we have here seen some of the names of heat treatment process. Annealing, quenching, and tempering are the three heat treatment process, and these are the structures which we have obtained from performing the heat treatment process. So let's see these structures one by one. In next video, we will also see various heat treatment process such as annealing, quenching, tempering, normalizing, etc. So what is perlite here in this para we will see. Perlite is a structure which is obtained in the metal by performing a heat treatment process. If the ferrite and cementite laminae in the perlite structure of the eutectoid steel are thin and closely packed, the microstructure is called fine perlite. Okay, if it is thin and closely packed, then the microstructure is called as fine perlite. If they are thick and widely spaced, it is called coarse perlite. The difference between the two depends on the rate of cooling through the eutectoid temperature. To understand these eutectoid temperatures, you have to refer iron carbon diagram. If you write in the comment box, we will surely explain iron carbon diagram also in my video, which is the site of a reaction in which austenite is transformed into perlite. Okay, if the rate of cooling is relatively high, as it is in air, fine perlite is produced. If cooling is low at it in a furnace, coarse perlite is produced. When perlite is heated to just below the eutectoid temperature and then heated at the temperature for a period of time, subcritical annealing, such as for a day at 700 degrees Celsius or 1300 degrees Fahrenheit, the cementite transformed to roughly spherical shapes. Unlike the laminar shape of cementite, which act as a stress razor, superoid spherical particles are less conductive to stress concentration because of its roundness shape. Consequently, this structure has higher toughness and lower hardness than the perlite structure. In this form, it can be cold worked because the ductile ferrite has high toughness and the spheroidal carbide particles prevent the initiation of cracks within the material. So this is the full explanation of a perlite. You can also write this by taking the screenshot in your examinations also. Now let's see the bainite. Visibly only through electron microscopy, bainite is a fine microstructure consisting of ferrite and cementite. Similarly to perlite, but having a different morphology, bainite can be produced in steel with alloying element and at cooling rates that are higher than those required for transformation to perlite. The structure called bainite steel is generally stronger and more ductile than perlite steel at the some hardness level. So here it is the conclusion that bainite is harder than the perlite, and we will see now martensite. Martensite is the hardest structure which is obtained in the heat treatment process. When the austenite is cooled at a higher rate, such as by quenching it in a water, its FCC structure is transformed into a BCT, body centered tetragonal structure. This structure can be described as a body centered regular prism that is slightly elongated along one of its principal axes. This microstructure is called martensite. You have to learn BCC, FCC, BTC, BCR extra structures which are a metal structure. Okay, so by learning iron carbon diagram and metal structure, you will more able to understand these structures. In this video, we have seen the heat treatment and types of structure. So in the examination, if the question asks is explain heat treatment and explain the various structures of heat treatment, so you can easily gain 7 marks or 4 marks. Depends on the question. So thank you very much. Please share, like and subscribe my channel. I am keeping you more theories in my videos because this theory you can directly take the snapshot, screenshot, and you can write in your university papers to achieve the good marks. Thank you very much. Please subscribe my channel. Thank you.